right, it's 101. Okay, again, welcome to the last session of BMP Summit. My name is Lakesh Sharma. I'm a BMP coordinator and assistant professor in Soil and Water Sciences Department, Gainesville campus. We have two speakers, actually three speakers today. Our first speaker is Dr. Lincoln Zotarelli, Associate Professor, Horticultural Sciences Department. Lincoln has worked a lot on nitrogen management in potatoes, along with irrigation and cabbage. We have two more speakers. One is Dr. Alex Bolques, Assistant Director, Florida A&M Research and Extension Center, Quincy. And we have Dr. Chang Gao, Professor of Food and Resource Economics. Welcome, everybody. Lincoln, the floor is yours. You're the first speaker.
Very good. Thank you, Lakesh. Good afternoon to everyone that took the time to attend the seminar today. We're going to discuss drip and sprinkler irrigation and subirrigation operation and management. I think the idea is to bring back some of the knowledge and about how we do the operation and management and the importance of those for a successful irrigation system. This is not something new, BMP has been on the floor, the discussion about BMPs being on the floor for quite a while. And during my search, looking for, information to prepare this presentation, I came across this 2003 IRIS publication on maintenance and evaluation of irrigation systems in the BMP era. So we're still in the BMP era, and we still have a lot of work to do. And one thing right at the beginning that we see, irrigation amount must reflect crop water use, no more, no less. And without a maintenance and constant evaluation of the irrigation systems, I don't think that can be possible. So just a brief layout of the presentation. I'm just going to mention the irrigation methods that we have in Florida. Operation and management, specifically for pumping systems, irrigation water quality, sprinkler irrigation, seepage and subsurface, microirrigation, and it goes followed by chemical treatments, what can be done, importance in fertigation and be aware of fertigation and the clogging problems, and wrap up with the final remarks. Important considerations first. Irrigation system is not only the hardware. What we see in the field on the ground, it's important. It needs to be properly designed, but we cannot forget operation and maintenance, training, knowledge, understanding how those parts, those moving parts work, and what needs to be done to accomplish its function. Proper design is imperative. Each irrigation method is designed to operate in a specific way and to irrigate specific crops. And so if we try to move across, changing this, we might be slipping on economic and environmental water quality problems, and that can lead to problems in crop yield. So we can consider management and operation as important as the design of the system itself, and it's fundamental to understand the capabilities and limitations of each irrigation system. In Florida, we have basically three principles of irrigation. So seepage, where basically we take advantage of the existing water table, and we raise that water table with groundwater to irrigate the crop. The system is almost 1 million acres of irrigated land in Florida. It's very significant. And the other two systems would be fall in the classified as a pressurized systems and would be subdivided in microirrigation and sprinkler. And they also account for, you know, a large portion of the land. You know, so on the bottom we see the estimation, you know, how it is distributed. One thing to keep in mind, CPAG has a very low irrigation efficiency, 20 to 70%. I believe is more on the lower end than 70%. I'll be surprised, 70%. In microirrigation and the sprinkler irrigation is much higher efficiency. So that means that the water that is pumped and compared to what the water that is delivered at the target, which would be the plant. So let's move to any one of those irrigation systems would have a pumping system. And if you will, it's pretty much the same consistent, you know, the same parts will be there for each one of those, of course, with some variations, but the principle would be the same. Pump, a vacuum breaker, low pressure drain, a check valve, irrigation going. And then you have the control valves, you know, with the electric pumping, you know, meter. And so it's not going to fall far from this design. But here are some examples. This is a centrifugal pump with diesel engine, you know, using surface water for vegetable crops. Here's a centrifugal pump with seepage irrigation with using an electrical motor. Here's a little bit more sophisticated, which is a submersible pump station with variable frequency drive. It can be used for multiple irrigation methods. So each one has its advantages and disadvantages, you know, but the same scheme is valid for all of them. So let's go briefly on what an operator needs to keep in mind. So maintenance programs should target, you know, it's basically to keep the pumping efficiency, you know, that is max, you know, minimizing power, operational costs, and extend the life of the equipment. Yeah, and this is a list of things that, you know, should be periodically, you know, the operator needs to be aware, you know, proper lubrication of pump and drive units, you know. If you have a turbine, it must be lubricated with water and oil. If it's electrical, the bearings for electrical pumps should be periodically greased, you know. Some pumps will require a periodic adjustment of impeller clearance to keep the efficiency. If you have, it's like you have in a car, you know, we need oil change, coolant, filters, you know, those are regular maintenance. And one point is, you know, unusual noises or vibrations, those are causes for immediate attention. Many of these, the repair decisions are not so apparent until quite severe. So that's why periodic maintenance is important, you know. And it's probably a good investment than having to replace entire pumping system because of poor maintenance. One important topic is, since installation is important to evaluate the performance and confirm the performance of this given of a given irrigation pumping plant. And based on that information, the development of history of performance can be we're taking notes and see, and any with that, if you have any reducing in flow or head, that can be quickly noticed, and even cost analysis can be done. So field tests would include static lift, pumping rate, drawdown, discharge, head, and input power. All right, moving on to the water quality, and this, what I mean in terms of water quality is the quality of the water, the irrigation water. So that's another important factor. Like we just discussed the pumping systems. Let's say if we're pumping sand, so sand is very abrasive, and that will kind of accelerate the degradation of the pumping systems. So these are an examples, and depending of the water quality, irrigation water quality available, there are some, for example, filtration systems can be put in place. They should be put in place anyways, but different filtration systems would be desirable for depending on water quality. In terms of water quality, we have here a breakdown of slightly moderate and severe related to the plugging hazard. That's more specifically for microirrigation, would be the most susceptible. Let's say would require the best quality irrigation water quality. So it would be the most unforgiving system would say. So we're looking at suspended solids, for physical factors regarding to chemistry, chemical, pH, dissolved solids, manganese, iron, hydrogen sulfide, hardness, which can be, which is calculated based on calcium and magnesium content, and also biological, the level of bacteria, concentration of bacteria in the water. So all of this can be accessed by sending a sample for water quality analysis. Simple and straightforward. You can get a report on how the water quality is standing. Moving on to sprinkler irrigation, thinking about BMP, thinking about water conservation, the goal is to maintain their design application uniformity. So we don't want your sprinkler irrigation system applying more water at the end of the field and one part of the field and less water, because that will compromise yield, will carry nutrients. So there is a series of consequences that are going to cascade if proper maintenance is not done. So the common problems that reduce uniformity, application uniformity, is low pressure, system pressure, usually low system pressure, incorrect nozzle sizes, plug, worn nozzles, worn pressure regulators for micro sprinklers, worn rotary heads, leaking gaskets, bearings. One advantage of the sprinkler system is easily you can visually inspect the system. On a practical side, I think probably the most important thing is to verify if the pressure along the system is matching with the design of the pivot. Or so in a practical way, you could turn on and run the pivot for a few minutes until it gets pressurized and steady. Then you check the pressure in several locations of the lateral or the center pivot, and you check also in the most likely to be the lowest, which is normally the end of the line, or if there is a higher elevation, so it would be on top of the higher elevation. So the pressure should match the design. If the pressure is lower than usual, that's an indication of leaks or pump is not pumping sufficient water. Pressure for the current nozzle package, could be the problems with that. If the pressure is too high or higher than usual, it could be an indication of plugged sprinklers. System is set up improperly, which will lead to increase of energy costs. So one tip here would be using these shader valves, which is basically what we see in tires. The pressure tires, the valves that we have in tires. Easily you can plug, a gauge, a pressure gauge, and check in several points of the sprinkler. All right. So it's not that difficult. Sprinkler is relatively simple. Let's move on to seepage. Seepage irrigation, very large area in the state and low efficiency. And more recently, there's been, kind of upgrading of this system towards tile drainage, subsurface drainage tile drainage, or irridrain. So there are several names for that, which basically is the installation of these corrugated 4-inch pipes, and of course changes depending on the design, but would allow the water to drain and also allow the grower to put water in and raise the water table. So it would move two ways. It's needless to say that there needs to be maintenance for those as well. And capacity of an open drain can be reduced as much as 50% in 1 year by sediments and a heavy growth weeds or bush. It is, and I found this in an old NRCS publication. That's terrible. To see a pipe clog like that. Can you imagine spending $3,000-4,000 per acre, and in a year later you have all these pipes in the field clogged. So there are a few techniques that needs to be periodic, for maintenance. Mowing ditches, also chemical control of the vegetation to minimize erosion. If sinkholes are spotted in the field, they need to be fixed the right way. Avoid entrance of animals and tree roots. Heavy equipment can dislodge and break the tubings, and if that happens, it needs to be fixed the right way. So repair blowouts, and so there are a series of techniques or practices that needs to be, the grower needs to be aware. There is a way to clean pipes, high pressure jet cleaning can be successful to remove ochre and silt and roots, but to what cost? So keep a record of the drainage tiles and positioning, maintaining the water table level, structures operational. So those are things that will kind of help maintenance of the systems, the drain tile systems. Land smoothing is another technique that periodically it needs to be, and that will minimize the differences in elevations. It will help with the drainage, and most importantly, will help the uniformity of the water distribution in the root zone. Microirrigation. Now you see that we're getting more and more complicated as we go in this, and more attention, more details in each one of these systems. So here's a brief layout of the microirrigation overall. So basically we have this control section, which basically similar to what we have discussed before. Pumping system, a backflow prevention device, which is required by law to avoid return of the water to the well. System controls and monitoring, control the pumps, water meter, pressure gauge, filtration systems, pressure regulator. Then going to the distribution part, main lines, submains, valves to control different zones, manifolds, air vacuum relief, another instrument, drip lines, and flushing lines. We're going to talk about each one of these parts individually. And it's very common with the systems to have an injection section with a chemical tank and an injection pump and an anti-siphon valve. If that complex is not enough, there's some growers using subsurface drip for water table control. So they are having a very fine control of the water that they're putting on basically what was seepage before to raise the water table. So that's a system that will require all those management that for seepage that I mentioned before a few slides ago, and also we require the maintenance for the drip tape. Considering that the drip tape, since it's buried, you'll be more susceptible to intrusion of roots or even intrusion of soil particles. So, but we're going to get there and how to prevent that. So microirrigation, same thing for the sprinkler irrigation. So the goal is to maintain their design application along the life of the system. So if properly designed, it's a very efficient system in terms of distribution. To achieve the design application uniformity, we need to ensure that water supply and pressure are correct. Filtration system is operational. Control valves, pressure regulators are properly installed and operational. Emitters are not plugged. That's probably the most important thing. Otherwise, you see situations like this, and I thank Dr. Simone for this nice pictures. Here's on your right, that's how it's supposed to be, the distribution of water via sprinkler, via drip irrigation. And on the left is what happened when you get sand in the system and you start emitters start getting plugged in. So distribution is not uniform anymore. Plants are not going to grow uniformly anymore, and yields are going to go. So we're missing out. So BMPs, that's a very important BMP. So at this point, I hope you understanding where this is going, and the consequences of mismanaging or not having the proper maintenance of systems, irrigation systems. All right, let's check in a few points that I consider being important, and this by no means is to cover all, but just a few points of so backsiphoning of soil into the emitters, So that's common when the system is shut off. Vacuum normally occurs and causes the soil particles to get in the system. Very problematic in subsurface drip irrigation. So the air vents can be installed downstream of all shut-off valves. Then you have an example of air vent here. And they should be installed in a way that they don't become the source, the entrance of contaminants in the drip tape, because they are mostly open up when they are not operating. So there is a way you need to install in a slightly higher installation, or even in a horizontal installation. For drip irrigation, filtration is it's necessary. We must have, otherwise the filtration drip system would not be used as long as we want. So filtration is basically to remove inorganic material, sand, silt, clay, algae, organic particles and residues. And consequences of not doing that is we're going to wear the pumps. We're going to have problems with clogging, and even the micro sprinklers can wear out. And one rule of thumb that the irrigation industry uses, so emitter diameters range from 0.01 to 0.007 inches, and we want filtration to be done 1/10 of the emission hole. And here you have two examples of algae grow in the irrigation emitter, and some sulfur slime blocking the irrigation flow. So those are serious problems for our irrigation, even with groundwater. So what type of filter? And if you start investigating, there is an infinite options, but considering the emitter, you need to consider the emitter design and the water quality. So I'm going to present 4 types of filtration systems. This is the most uncommon one. Centrifugal. I honestly have not seen anyone this centrifugal filter operational here in Florida, but it's basically because it's effective for sand and large particles, and for drip irrigation and for sprinkler, you probably need to be more efficient than this. Very common is a screen filter. A variety of shapes and size, is based on the mesh size, the opening per inch, and determines the fitness for the mesh material that needs to be removed. It's good for sand and organic material, some scale. Should not be used as only filtration system. So there is, when there is organic contamination. So it's a good system, but not efficient enough if you're working on drip irrigation, for instance. So probably for drip irrigation, a disc filter would be the most adequate, which is basically a stack of washers, and that provides a much wider, much larger surface for filtration than the screen filters. So the size of these filters are equivalent to the screen of mesh of the filter side of the filters, the previous filters I represented. Also require a periodic cleaning, similar to the mesh filter. And this allows back flush, which is a very important, because there are some systems that would do that automatically. Here's a good example of a very efficient filtration system. So if we didn't have a filtration system, and all of this would be plugging the emitters, and this needs to be very periodically cleaned. Going on more sophisticated systems, we have media filter or sand filter, available in different capacities and very efficient for colloidal and organic material. And the degree of filtration depends what kind of purpose you want, and also depends on the rate flow of your system. And most of these are equipped with backwashing process as well. Talking about moving on and down to the pipeline, flushing irrigation lines. This is also very important, so that would minimize, even with filtration system, we will see some sediments moving on into the pipes, and we need to do a regular flushing of the irrigation lines. So flush should be made at the end of each line, starting from main, sub-main, and laterals. It's part of the regular maintenance. So today we have a variety of self-flushing valves commercially available, and here are some examples, that could be installed at the end of drip tape or end of main. And they would let the water move out of the system until pressure is built up and then they would automatically close. Chemical treatments, chemical treatments also can be preventive or can be done after a problem has cure. So causes of plugging systems of bacterial, algae, iron, manganese, remember of the water quality, calcium or precipitation of calcium, manganese, or root intrusion. So basically we can we can control or we can prevent, and be aware that chemical injections should be according to label directions and local laws. So injection of chlorine, probably the most common one, with sodium hypochlorite, which is household bleach, and depending on the concentration, would be different targets. 1 to 5 ppms, bactericide, oxider of iron. 100 to 1,000 would be more a burnup of organic material. There's some, several schemes. These are suggestions. We could have maintaining every time irrigation occurs, apply 1 or 2 ppms of free chlorine in the laterals, or we could be injecting in intervals of like a week, but in a higher concentration, about 20 ppms, long duration, long enough to last, to fill up the whole system. Or it could be a slug treatment, the more higher concentration, 50, up to 50 ppms on a weekly basis. And one point that we should be aware that chlorination is very ineffective if the water pH, the irrigation water pH, is above 7.5. So in this case, we need to do an acidification of the water before chlorination. But application of acids are also a preventive way to avoid clogging. So sulfuric acid, hydrochloric acid, or phosphoric acid can be used for this purpose. The amount depends on the buffering capacity. So we need to know the water, the chemistry of the irrigation water to decide how much we can apply. And there is guidelines that you can reach. There is an easy publication below. Let's not forget that phosphoric acid is also a fertilizer that can be used for water treatment. So we're working, injecting acid in a drip irrigation system. We're dealing with high concentrated material, acid that, so we should be aware that no metal and acid resistant mixing tanks, so if you don't have this kind of systems, you probably should not be doing that. Diluting acid, always add acid to the water, not the opposite. And the acid injection point should be beyond any metal. Another common thing that we see, especially in Florida and probably blueberries, is use of urea sulfuric as a fertilizer, and blueberries like a more acid environment in the root zone. So that can be used, and they can be used to lower the soil pH. The soil pH can lower the water as well, the pH of the water. Another problem that can be very distressing to growers is root intrusion. That's probably more for perennial crops. It can be minimized by application of chlorine, and even weekly drop of the water to pH 1 to 1.5 when the crop is living, and superchlorination, and that should be done when the crop is not in the ground. That can be also preventive. This is getting more on the topic that I like, which is fertigation and problems like clogging. So having a drip irrigation system, fertigation can be used to spoon feed the crop with fertilization, but we need to be aware of few things. And safety is very important. We're dealing with fertilizer solutions, you know, and concentrated solutions. So we don't want spills, and we don't want, you know, we want uniformity of the systems. Growers need to be aware of likelihood of the fertilizers to clog the fertigation system. That can happen. And fertilizer, they can react, you know, in reactions of fertilizer injecting the irrigation system. So all these points are very important to keep in mind to avoid problems like this one, where a grower that was applying some form of 20-20-20 he decided to add calcium nitrate for tomatoes, and calcium nitrate reacted to the phosphate from the ammonium phosphate and became calcium phosphate, which is insoluble. You know, had to rip off his whole drip irrigation. So the good thing is we can always do a jar test before injecting, see if these fertilizer are compatible, or do application in different days and making sure that the line is flushed before injecting the other fertilizer. And also check the compactability chart. Well, we're moving towards the final and the tail end of my talk. And you know, when I was preparing this, and so we need to make this, you know, the operation and the maintenance in a very more fluid way, more routine based, that the grower and the operator can, you know, pinpoint some. And there are some flow charts. There here, the Irrigation National Engineering book, that just zoom in. And so just to kind of go a little bit on a, so acquire complete components and information, instructions. Did you study and fully understand the operation instructions? If you have not understand this, so go back and study it again, and then move on. And gives you, you know, so based on this, you can customize, you know, a routine for operational, you know, read emitters, set the fertilizer injection, open the head valve, you know, step-by-step operation. Same flow chart can be done for maintenance, you know, determine water quality, you know, in the periodic way. That can be very useful in a checklist for the operator. You're just a brief overview of how, and this can be found in the handbook. So at this point, do you feel overwhelmed? Probably yes. It's a full-time job. It's not a simple job. Requires attention to many details, but it's a very important job. And there are many already, you know, extension agents giving support to growers. And there is a mobile irrigation lab, which is doing a tremendous job trying to increasing the technical assistance to irrigators, you know, and which is a collaboration between the USDA and RCS, FDACS, and the Water Management District. And there are 18 sites across the state. You know, they will come to the farms and help on the design, help identifying problems and solutions for irrigation systems, you know, always trying to figure out better ways for water conservation, you know, and maximize the potential of the water distribution. And so here's an example of the series of tests that they do, and they can to identify problems in irrigation already installed irrigation systems. So take home message: proper design is fundamental. It's a fundamental BMP. knowing and monitor irrigation, water source and quality, develop a schedule for fertilizer injection, develop a schedule for irrigation scheduling, develop a follow-up maintenance program, and develop a schedule for irrigation based on the crop management. With that, I have here some additional references, and I'll probably move on to the next speaker, Lakesh.
Thank you, Lincoln, for this presentation. We have a question. I think the question is from one of the panelists. The question for the audience is, for subsurface drip, the subsurface tube is the same as a T-tape drip line, and what about the soil depth placement?
There are, if you look at manufacturers, they will have specific drip tape with specific emitters for subsurface drip, and those are to minimize intrusion of particles, sand or root. So they're different. They're different than the regular drip tape. For subsurface drip, normally the thickness of the wall is higher, because it's not a system that you're going to be replacing every season. So it's expected to last much longer. You know, there are some studies in Kansas, for instance, with 15, 20 years, you know, of drip tape. Of course, well maintained. And the depth depends. For subsurface drip, you know, looking at raising the water tape, you're looking at the high flow drip tape or high flow hard tubing, and the depth of irrigation should be above the soil impermeable layer. At the research farm in Hastings, we were able to reach about 18, 20 inches of depth, and that was sufficient to more uniformly raise the water table.
Lincoln, I have a question. Is there any control for the rodents? Is there any potential damage from the rodents, like moles, stuff like that?
That's common, you know, especially on surface drip. I don't know what kind of control you can have. But only having some traps, and then the wildlife environmentalist might not like me, but that could be a problem. We have seen, but I'm not sure if it's a widespread problem, you know, but could be. We have some reports of that could be significant damage. I always carry in the truck some of those splits, you know, to fix some connectors to fix the drip tape.
I'm glad I'm not living in Australia. There is a rat plague in Australia going on now. All right. Okay, I don't see any other question. So, Lincoln, if you hang on till the end of the session, there is a possibility that there will be more questions. All right, we have two more speakers for our rest of the session. Alex Bolques and Dr. Jiang Gao. Alex, if you want to share your screen, you can go ahead and start your presentation now. Perfect. Floor is yours.
Can you hear me now?
Yeah, I can hear you now.
All right, thank you. So the topic is agricultural best management practices, understanding and bridging the gap between consumers, growers, researchers, and stakeholders. And it's part of a funded AFRI grant, and I'll provide that information in a little while. With me today is Dr. Zhifeng Gao, and he is the project PI. And I have a sub-award with Florida A&M on this project. So basically, going forward here, we're trying to meet the food industry and consumers' demand as it relates to labeling or green initiatives that helps to identify products that are produced in a sustainable manner or in such a manner that it is actually having value in environmentally speaking. Under intense pressure, and this is an article, and I've sort of enlarged these bullet points here that I think are important. Under intense pressure to meet demand for products that measures up to consumers' personal values, US food companies are feverishly working to rejuvenate their brands with green initiatives. And you can think of these initiatives as actually actual product labeling and the value behind a product label when you make that selection. This article was done in 2020. Last year, the International Food Information Council had a survey on food and health, and they found that over half, 54%, responded that at least labeling is somewhat important, and that products that they buy, that they would like to buy, should be produced in an environmentally sustainable way. Among those 54%, many consumers looked for specific labels or attributes to assess whether their belief a product is environmentally sustainable, and 51% perceive products that are locally produced are also environmentally sustainable. Now, this is products that are, grown near to their homes and places of business, but necessarily, if you think about it, that may not be true. Followed by products that are labeled as sustainably produced, and these are about 47% of the respondents, along with products labeled as non-GMO and products labeled as organic. And so all these products have value, all these products have a definition, and actually bridging that gap and understanding about the food you're buying and how it was produced is the impetus for this project. So in short, sustainable is no longer a fad. The heavy hitters of the retail food industries are jockeying for position and actively recruiting suppliers, farmers and ranchers, ready and willing to help meet consumers' demands. And again, this is all being driven by consumers. So BMP and sustainability. BMPs are broadly defined as a set of sustainable practices that aim at optimum plant production with minimal adverse impact to the environment. And this is according to the Office of the Federal Registry. Our project, which actually looks at BMPs and actually try to make that bridging that gap between BMPs and sustainable practices along with best management practices. In this project, we are looking at actually how these labels can help producers to have more value in the products that they sell and thereby educate the consumer of the products that they're selling through either these types of BMP labels, sustainably produced labels, and maybe conservation practices labels. So the project is improving profitability and environmental stewardship for small and medium-sized farms by identifying new market opportunities. And this market opportunities is the labeling portion of this grant program. In this project, we focus on BMPs for specialty fruit and vegetables that have been broadly categorized by FDACS as having some sort of management practice. And of these, we have nutrient management, irrigation management, sediment and erosion control, water resource protection, integrated pest management, and recycling and waste management. These are all practices that can be thought of as being conservation practices, sustainable practices, as well as best management practices. So as a bundle, if you can set aside and be able to identify what these mean to the consumer and then educate them so that they understand when they purchase that they are actually getting a product that has sustainability and best management practices in mind. In most states, state and federal agencies have established and continue updating their BMPs as an essential means to improve environmental stewardship as it relates to agriculture. BMP programs are based on available scientific data and generally share 4 common goals. So the first one is to maintain or improve the quality and quantity of crop production, and I think this one we understand very well. To maintain or improve profitability, and this one I think we all understand very well as well, especially the grower. To retain a stable supply of crop inputs over the long term. And this is as it relates to sustainability and where you get your equipment and supply and how sustainable your operation is. Lastly, the sum of recommended practices should have a positive effect on the environment and social component of agriculture. And of course, all of this will feed into the general economy. Many BMPs, especially the structural BMPs, require additional investment of equipment, frequent water and soil testing, and labor time management, so that adopting BMPs can lead to higher production costs than traditional farming methods. So you're doing an intervention that is actually causing or that is improving conservation practices that are sustainable and that you're doing the best practice that is known at the time. And so therefore these have a dollar cost behind it. And government supported cost share programs have been utilized to make BMPs more economically feasible. Actually, it's one of the reasons why we can get some growers to adopt BMPs, because there is a little bit of cost sharing involved. However, large growers with significant resources often have a competitive advantage in adopting BMPs, mainly because they have resource intensive operations. They have more technology, perhaps more individuals that can do the work. And so it gives them a greater advantage and ability to adopt these BMPs. And the same can't be said about small producers or even mid-sized producers. In Florida, the average size of BMP adopters of all types of farms, including here in Florida, citrus, cow-calf, dairy, equine, fruits and nuts, and so on, was about 440 acres in 2017 on average. This amount of acreage is larger than 90% of the farms in Florida, and we all possibly know that small farms are the largest component of farms in the state. So by having large producers at the table, really, you don't have in terms of numbers of individuals adopting these BMPs, the numbers are just not there. And so we need to make a better effort to include mid and small farm operations. So some reasons for small growers that are slow to adopt BMPs that are said to be the cost of implementing the BMP itself. Perhaps they don't have capita to implement these. The need for advanced technology, again, same reasons. And then the potential need for higher level of education to understand and implement the practices. And this is really where extension fits in very well. Small and medium-sized farming operations face different barriers to production when compared to large operations. And again, it goes back to large operations have resource-intensive uses and equipment that allows them to just be a little bit more competitive than non-large farms. Small and medium-sized farms that are slow to adopt BMP may be due to the lack of information about market opportunities. Again, and then here is that the label, the BMP labeling, maybe perhaps has not transferred to the consumer to actually, for it to mean something as much as maybe perhaps the organic label, which seems like everybody now recognize. Small and medium-sized growers actually were the early adopters of organic farming. And eventually that took off, and big farms have actually been able to benefit from organic labeling. Like BMPs, organic production is accompanied by higher costs, just like BMPs, relative to the restrictive use of chemical fertilizers and pesticides, and the potential yield reduction that you can have because of organic production. Organic production also requires more management time to comply with the complex rules of the organic certification. And so you would think that these efforts would deter small farm producers from getting into the organic game, but actually they understand it and they're willing to do it, and they understand the investment in time and resources. And this is where we want to transition with agricultural BMPs. Key differences between organic and BMP enhanced production includes organic food is identifiable in the store and priced much higher than conventional food, while food produced with BMP enhanced conditions is generally difficult to differentiate from conventional foods. Again, a miscommunication. As a result, the increased cost of adopting organic practices can be offset by the price premium associated with organic foods for BMP labeling. If the food produced with BMP enhanced production system can generate price premiums, that is the argument, similar to that of organic foods, then small and medium-sized growers may be more likely to adopt BMPs because they want to be able to boast that they are using BMPs as a marketing opportunity for them for the products that they're growing. Consumer demand is driving new marketing opportunities for products grown with labeling such as organic food, food produced with less or fewer pesticides, and food with eco or sustainable labels. Consumer buying, really, it's very complex, and it can take into account things like age, gender, education level, knowledge of the foods that you're selecting or of the foods you eat, alternative crop production methods, and other types of methods that affect consumer buying. Much of the research on the demand for other sustainably produced products has been devoted to estimating consumers' willingness to pay, or WTP, for products associated with reduced pesticide use. So they see pesticide reduction as a very positive thing, as a very healthy thing that they want to be able to continue to do in their lives. And so having to understand how much are you willing to pay for this organic food, or for this BMP food, or for this conservation practice that was used to produce this food is something that the consumers will have to be educated so that they can be able to determine or tell us what or how much are they willing to pay for such products. Dr. Gao will talk about preliminary studies, but in our preliminary studies prior to the project, it shows that consumers' willingness to pay for strawberries with different environmental benefits related to BMPs are significantly higher than that of conventional strawberries and differ significantly. However, small and medium-sized growers may lack the knowledge to most effectively market their products. And again, this has to do with the adoptions of BMPs and being able to take advantage of the marketplace labeling. So closing the gap in Florida and other states, Ag BMP adoption is supported with cost-sharing incentives. It has been shown that Floridians are willing to pay for water quality improvements that directly impacts them locally. So a lot of these ag producers that are putting in place these BMPs to reduce basically water pollution, and if consumers see that in the marketplace, they will be able to recognize that and make their decisions in terms of purchasing power. Since much of the produce grown by small and medium-sized farms is sold in local markets, new marketing methods and BMP labeling may provide a vehicle for converting consumers' willingness to pay for water quality improvement and other conservation practices into an actual price premium for the producers, protecting and improving local water quality and quantity. Therefore, identifying new marketing opportunities, determining consumers' willingness to pay for sustainable produced products, and delivering this marketing information may be an important component to increase small and medium-sized farm income and motivate growers to adopt BMPs. Extension programs, which we will have a component of the grant is an extension activity or program. From this research can bridge the information gap between consumers, growers, and stakeholders to assist small and medium-sized farms to gain extra income from these growing markets and can lead to economic and environmental sustainability in the long run, which again, all will feed into the economics and the economy. So at this point, this is how much I will share, and Dr. Gao will continue on with the next 16 slides. I will stop sharing.
Okay. Let's see. So can you see my screen?
Yes, we can
Okay.
see. It's look good. Yep.
Okay. Okay, thank you, Alex, for talking about the introduction. And here I will talk about the 3 objectives of our research project. And later on, I will also talk about some of our preliminary results from the consumer study that's actually is going on now. As Alex mentioned, the key objective of this project trying to bridge the gap between consumer, grower, and stakeholders. The first thing you want to know, in general, you want to know whether there is a market-based approach to motivate more growers to adopt BMP, especially small and mid-sized growers. So that's why the first objective is we need to identify whether consumers are willing to pay more higher price for BMP labeled products. So that's why our first objective is trying to determine consumer knowledge, perception, and attitude towards sustainable agriculture practice. Specifically, in our case, the BMP practice. as well as they're willing to pay for fresh produce, produced labeled with different BMP labels. So as you can notice, the first one, we want to know consumer attitudes, perception, and understanding of BMPs, and what's the relationship between sustainable agriculture practice and BMP. Does consumers know, have a general knowledge of sustainable practice, and how about their knowledge of BMP? And the last thing, definitely the most important thing, if we try to develop some certification program and label the product, that's produced using BMP, where the consumers want to pay a high price for those products, so that growers can cover their additional costs by implementing the BMP practice. So we kind of like hypothesize that consumers are willing to pay for fresh produce that is marketed as environmental friendly, and versus those traditional conventional products. And this has been observed in the market. Actually, in the current US market, there is some website called Eco Index. They list that there are about more than 200 eco labels currently in the US market. And of course, in our case, we want to know, say, if we have the BMP label product in the market, will consumer want to pay a higher price for it? So to achieve this goal, we will do an online survey, to national online survey, actually multiple round national online survey, to learn whether consumers, when faced with hypothetical purchase decision, actually we will use the choice experiment, something very popular approach in market research and economics, to see whether they want to pay a premium for specific products labeled with different labels. And in our kind of research, we designed several BMP labels because BMP grown, and then we have another label, BMP, also certified BMP, but we emphasize something on water quality, and we will show those labels later. And we have a second, also BMP, certified BMP, but also emphasize on water quality with different wording. We kind of assume if we have different wording, that wording may have different effect on consumers' purchase behavior. And of course, you want to know whether the BMP can compete in the market with other currently labels in the market. So that's why we also want to know whether consumer willing to pay for USDA certified GAP, the Good Agriculture Practice, and the GHP, Good Handling Practice program logos. USDA have official logo for those program. And another one is USDA certified organic logos. So the key thing from this online survey, we will try to document whether or not consumers are willing to pay a premium for BMP grown fresh produce. We will use multiple products. Currently, we use strawberry. Later on, we will use the tomatoes and other fresh produce. And the second objective, basically, we say whether we want to know whether those potential market opportunity can motivate growers to adopt BMP, so especially small and medium-sized growers. So that's why we want to know whether small and medium-sized growers' perception and attitude towards sustainable practice, in our case, BMP, and technology, and how different attributes of those BMPs. Lincoln has presented those irrigation BMP, and of course, if we say define those BMPs, they can have different attributes. How easy it is. I mean, what's the cost of installing those equipment? How easy it is to maintain, the BMP practice, and whether the product from BMP can get high premium. Different BMPs have different features. So we want to know, I mean, what attributes are most important to growers, and what may be a motivation for them to adopt BMP. And of course, the most important thing, we want to know whether the marketing information from our consumer studies, if we identify there is high premium for BMP label product, whether those will be a high incentive for grower to more likely to adopt BMP. Okay? And so basically, this objective, we want to access special crop growers' understanding of sustainable farming practice, particularly BMP. And also we want to know what's the barrier, potential barrier that prevents their adoption of BMP. Definitely, I mean, we can think about it, the cost maybe one thing, the time for management maybe another thing. This is something we want to figure out through our study. And we also want to determine how agriculture BMP and consumer willing to pay can influence their adoption practice. So we will do a grower survey and to achieve the goal in objective 2. And we through the grower survey, like I mentioned, we want to determine grower attitude toward the BMPs and the key barriers and for their adoption of BMPs. And also we want to examine the impact of new market opportunity on their potential adoptions. And we will use key marketing information from our objective 1 as a primary component in the grower survey. And like Alex mentioned, we will follow special crop. I mean, we know there are Florida have all kinds of different BMP for different industries, but in our project we focus on the special BMPs related to the special crop. That's why we will survey citrus, grower, vegetable, and aromatic crops, nurseries, and special fruit and nuts crop. Almost cover majority different type of crops in the Florida. And the type of the BMPs, we try to be inclusive, but still, I mean, this is just what we propose to do. I know it's very complicated. So later on, we may make some changes, but we want to know what's your knowledge, attitude toward nutrient management BMP, irrigation management BMP, and so on. Okay. And to answer our key question in this project, we expect to find out the growers are more willing to adopt BMP if there is sufficient price premium associated with appropriately marketed sustainable products. This may be especially true for small growers because they use direct marketing. Most of them use the direct marketing to sell their products through CSA, farm market, or to restaurant. And if they have the chance, to promote their product as environment friendly, maybe consumers are willing to pay more, and the grower can get those premium directly rather than going through the wholesale and the big retailers. So the last objective, of course, is the extension objective. We want to deliver information from consumer study to growers to stakeholders, and we'll have different extension program, so that to enable small and mid-sized growers and managers to develop the skill and utilize our information for their decision making, such as in marketing and production decisions. So this may based on the access to production and marketing for foods produced with BMPs, based on the adoption of BMP that would allow them to develop new marketing strategies and to adopt BMP regarding various BMP outcomes, and also developing some outreach programs that inform growers how to improve their compliance with BMP and how to make use of marketing opportunities associated with their compliance. Actually, we have last year we have several meetings with staff from FTEX and I think Michael Dux, who is also here. We have an advisor meeting. We are trying to see, I mean, whether we can really make it happening in Florida and through FTEX BMP program, and whether they can certify those growers and allowing them to use the BMP labels. But that's they want to see our preliminary results, and then maybe this may be part of the extension program. I mean, to help the stakeholder to make decision about whether they want to have a BMP label program. And this definitely is very essential for this project because we want to make some real impact. So it's that's why it's very important to disseminate the research funding to stakeholders, small and medium-sized growers and decision makers working on the related policy. And the small and medium-sized grower may directly benefit from the result from this project if we can figure out, whether consumers are willing to pay more products labeled as BMP, and what type of BMP label may give them a high premium. And so if there is market premium, we expect to see the increasing number of growers are willing to implement the BMP. And we will have different outreach components. We will have a BMP labeling process development, including whether this may be possible for FDX to develop a BMP labeling certification program. And of course, we have different workshop and curriculum development and trainers trying to deliver information from grower survey and consumer survey to the extension agent. And we expect to see there is a knowledge gain among small and medium-sized growers and among decision makers. And of course, we will have some publish our results online through journals and maybe other social media activities. Okay. So those just overall summary of the 3 key objectives of our project. And here, actually, like I mentioned, we just send out our online survey, the consumer survey, and this national survey. We focus on the adults, primary grocery shoppers, and strawberry consumers, because the product we use, focal product we use is strawberry, and later on we will try to use other different products. We plan to collect 800 completes, and currently Qualtrics just have to collect 258 samples. Here is I didn't present the demographic information, but here just let you give you some picture about the consumption frequency of strawberries. And as you can realize, in our sample, most of those respondents at least consume those strawberries weekly. And the first thing we want to know, what's the knowledge of consumers for sustainable agriculture. We ask 3 simple questions trying to measure their subjective knowledge. So basically, the first one is compared to an average person, I know more about sustainable agriculture practice, and they will answer questions using 5-point Likert scale, say strongly disagree to strongly agree. And also, I know the environmental impact of sustainable agriculture practice. And the last one is I know how to buy products and package that are better for the environment. And here is a result. As you can see, actually, the consumers think they know sustainable agriculture pretty well. Especially, the last one, know the product and the packages better for the environment. And almost about 75% consumers say they know how to, buy the products that are more environmentally friendly things. And also more than maybe about 60% think they know the environment impact of sustainable agriculture practice. But interestingly, less than 50% don't think they know more about sustainable agriculture practice comparing to average persons. Okay, but in general, we can see the subjective knowledge of consumers are pretty high sustainable agriculture practice. And then we want to know, okay, specifically for best management practice or BMP, what's consumer knowledge? Not surprising, I would say. And we just ask them, have you ever heard of a agriculture best management practice or BMPs before this survey? And about the 67% say no, they never heard about this term. That means, although as a for research institute and extension, we talk about a lot of BMPs, but among general public, consumers have very limited knowledge on BMPs. Okay? And here we want to know, specifically, do they will be more challenging to those respondents? We ask them, what do you think the primary focus of BMPs? So as researchers and in this area, we know the key primary goal of best management practice is focused on water quality. And as you can see here, less about 9% of the respondents know the primary goal, of BMP is minimize water quality impact. And about 50%, select all above, including increase the use of renewable energy. And I don't think this is very related to BMP at all. And improve soil health. This may be related. And increase food safety. I don't think this is a primary focus of BMP. And the other things, including the air, reduce air pollution, and increase the fair trade. And so from here, we can see in general, although consumers think they know sustainable agriculture practice pretty well, but specific for BMP, they have very limited knowledge. Okay, and then actually we have in the survey we explain what the BMP is and give consumers some information, very baseline information, and then we ask them their perception of the BMP produced special crops. And for comparison purpose, we also ask their perception of organic products. So we ask their perception from several dimensions. We include the social benefit, health benefit, and environmental benefits and economic benefit. Definitely, we also have options that no benefit. And this is a multiple choice question. Basically, we say, okay, what type of benefits do you perceive from the following attribute of fresh produce? And we have the BMP, we have organic. We also have, GAP and THP and something, but I won't present result here. And like you can see, most consumers, respondents think BMP have, a lot of environmental benefits. More than 75% respondents think BMP products have environmental benefit, and they also, of course, they also perceive BMP product have some economic benefit, health benefit, and social benefit. And for comparison purpose, we can see for organic, and the about 75% think organic have a health benefit. This is kind of consistent with what's going on in the literature. Although there is still debating whether organic have a health benefit, but consumers think organic product have some health benefits. And a little more than about 55% also think organic product have some environmental benefit. And of course, you have some economics and the social benefit, but comparing to BMP, we can see the perceived social benefit and economic benefit actually is lower than that for BMPs. So these results generally tell us, after knowing what the BMP is, there is a very positive impression of BMP, perception of BMP produce product. And that's why we want to know, okay, whether consumer want to pay more for BMP produced special crop. In our case, we use a choice experiment, ask them, say, if they are going to buy a strawberry in the grocery store, and they are facing with different type of product, strawberry with different labels. And here, just one example, we can see in the first product, this strawberry may have the certified BMP, preserving water quality, and then have the USDA organic, have the USDA GAP. And of course, we tell them where this strawberry is from. It's okay product of your state. And if the consumer is in Florida, that means this strawberry is from Florida. If the respondent is in California, that means this strawberry is from California. And then we have the price for these strawberries. And this is the second strawberry with different labels. And then consumers will choose one of them that they like the most. And of course, if they don't like those three strawberries with all the labels, they can say, okay, none of this, I will forgo this opportunity to purchase those strawberry. And here is another choice set in the choice experiment. Like you can see, we try to change those labels and change those prices at the bottom. And then consumer will make another choice. We have, different those attributes combinations. We have in our experiment, we have 10 those choice, we call choice scenario for respondents to make choice from. Okay, and here we jump to the result directly because I don't want to go to the details about how do we estimate the models, get the result. The interesting thing we can see, consumers are willing to pay, strawberries with some BMP labels. And the first thing, the most obvious thing we can see is, the willing to pay for BMP labeled product, BMP preserving water quality with this label, comparing a product without this label, the premium is about $2.9, and this is kind of a little higher than that for USDA certified organic. And maybe those two numbers are not significantly differently, but at least it's kind of almost equivalent. For BMP certified product, is they can get the same premium as a USDA organic product, and then the GAP and the GHP, get the kind of, if you compare those labels, the lowest premium of willing to pay, and the consumer don't quite differentiate between the strawberries produced from their own state and those labeled as produced in the US. Okay, and of course we can see those three labels have different impact on consumer willing to pay. That means the claim, the label format do matters. Okay. So here is a conclusion from those preliminary research result from consumer study. We can see the self-assessment of knowledge of sustainable agriculture is high, but their knowledge for BMP best management practice pretty low. Only 30% heard about BMP, and less than 10% have know the key goal, key focus of BMPs. And BMPs are associated with more positive environmental, social, and economic perception compared to organic food. And consumers are willing to pay more for produce with BMP labels. And we also see the claim on BMP labels matters. If the BMP plus some wording like preserving water quality have the highest willing to pay, and the willing to pay for pure BMP label without any indicating any environmental benefits has the lowest willing to pay. Okay, and yeah, that's all my presentation today, and I would like to thank USDA, NIFA for supporting this project. And I also want to thank all my co-PIs on this project. We have the Tatiana, and who is the economist working in the water economics, and Derek is focused on extension and the budgeting. And James, I think when we write the proposal, he was on this project. I think he already retired, and of course Alex and my students, Azar and Yudi. Thank you, Lukash. Thank you.
All right, thank you, Zhang, for your presentation. Okay, we have a question for you. What criteria are used to denote small and medium-sized producers, acreage, gross sales, or other factors?
I think there are different criteria to denote a small and medium-sized producer, but the USDA, I think, have a definition about what's a small and medium-sized producer. But I cannot remember exactly what's the criteria. Yeah,
it's 250,000 or less for small farms, and 350 to $1 million for mid-size, and then anything higher than that is large farms.
Great, Alex. Thank you.
I was able to look it up because I saw the bubble pop up.
Okay.
Thank you. All right, we have one more question, but before going ahead, we have a survey for our audience to reply to us for the presenters to improve their presentation and the BMP Summit for the next year. Please click on the survey. It's less than 60 seconds. You can answer that. There's the CCA credits here on the screen. You can use this QR code for your CCA credits. All right, while you're doing that, I can read out another question here. Do you have additional survey information such as demographics, response rate, etc. to share, or a link to the paper if published?
Yeah, we do have those information, but like I mentioned, actually it's still going on.
Butler.
Yeah.
Alex Bolques.
Okay.
Don't have paper yet.
Put you all together.
It's been a while back.
They got quiet.
Right.
Okay, I think it's back.
So we have somebody has the microphone
Yeah,
on.
Lakesh, we have the demographic information definitely, and a response rate. I don't think online survey they don't think they have the response rate, and they may have something called complete rate. This quite a different concept comparing to paper survey, and yeah, the survey is still going on. We hope we can get this information out sometime maybe next year, early next year.
Thank you. All right, we do not have any more questions. Would like to say thank you to our presenters and Dr. Dukes, if you are here. You want to say a word? This is our last session. Maybe thank you to the audience for being patient for 3 months. We are really grateful for our amazing speakers. This BMP Summit went very well. Thank you, Emily, for coordinating all these efforts. Thank you to Sebastian Galindo for developing a survey with me. This survey would help us in improving this summit for next year. We have a BMP core team that helped.
I'll reach out to you.
I'll say we had a BMP core team that helped me to select the topics for this BMP Summit. I will be reaching out to them again for the next year topics. If you find to our audience, this message is for the audience and the speakers. If you find any topic that you are interested in that we need to cover for next year, please reach out to me and I will discuss that topic with the core team. Okay, Emily, thank you. And I'm not seeing Dr. Dukes here. Okay, I think he left. Okay, thank you, Alex. Thank you, Jang. Thanks, Lincoln, for the presentation. I think that's probably it. Thank you, audience, for your patience again. And if you have any additional question for our speakers, please reach out to me or speakers directly, and I will address that question as soon as I can. With that, thank you very much. Have a nice rest of the day. Thank you. Bye-bye.
Thank you. Bye.